integral of 3x square minus 10x plus 15 over x minus 1 x square plus 2x plus 5 dx. So we want to write this complex fraction as a sum of two simpler fractions. So x minus 1 factor, so a over x minus 1 plus x square plus 2x plus 5. This does not factor, so we keep x square plus 2x plus 5. It's a degree 2, so we want to write degree 1 polynomial on the top, which is bx plus c. Now we combine these two fractions, so the common denominator would be x minus 1 times x square plus 2x plus 5, which is essentially this. They are distinct, so a times this plus bx plus c times x minus 1. So the top is equal to a times this plus bx plus c times x minus 1. Now from this equation we should be able to find the values of a, b and c. Okay, so x minus 1, this becomes 0 for x equals 1. So let x equals 1, then we have 3 times 1 square 3 minus 10 negative 7 plus 15, 15 minus 7 8, 1 minus 1 0, so 0 times this 0, so 1 plus 2 3 plus 5 8, 8a, divide by 8, we get a equals 1. Okay, let x equals 0 because b times 0, x is 0, so this will be 0, and a is known, so we can find the value of c. So let's take x equals 0, then 0 minus 0 plus 15, 15 is equal to 0 plus 0 plus 5, 5a, a is 1, so 1 times 5, just 5, plus b times 0, 0, c times 0 minus 1, negative 1, so negative 1 c, negative c. Okay, this is negative c. So subtract 5 from both sides, 15 minus 5, 10 equals negative c, or c equals negative 10. Okay, since we know the values of a and c, let's take x equals any other number. 1 0 are used. Let's take negative 1, then 3 times negative 1 square, just 3, minus 10 times negative 1, positive 10, 3 plus 10, 13, 13 plus 15, 28 is equal to negative 1 square, just 1 plus 2 times negative 1, negative 2, 1 minus 2, negative 1, 1 minus 2, negative 1 plus 5, 4a, a is 1, just 4, plus negative 1 minus 1, negative 2, b times negative 1, negative b, plus c, c is negative 10, times this is negative 2. Let's distribute negative 2 inside, so subtract 4 from both sides, 28 minus 4, 24 is equal to, let's distribute negative 2 times negative b, just positive 2b, negative negative positive, 2 times 10, 20, subtract 20 from both sides, 24 minus 24, so 2b equals 4, or b equals, divide by 2, we get 2. Thus we have all three unknown constants, a equals 1, b equals 2, and c equals 3. So this antiderivative of this fraction is antiderivative of this plus this. So let me write that down here. Now the integral is a over x minus 1. A is 1, so 1 over x minus 1 plus second part, second fraction, bx plus c. b is 2x plus c is negative 10, so 2x minus 10 over x is squared plus 2x plus 5 dx. Okay, this first part is easy because the top is derivative of bottom, so the antiderivative is natural log of bottom. plus. For this, now there are several ways, so let me show you two methods for just this part. Let's look at this carefully. We have x squared plus 2x plus 5 on the bottom, and the derivative of x squared plus 2x plus 5 is 2x plus 2. Okay, 2x plus 2. So let's make this 2x plus 2. 2x is already there, and I need plus 2, so that this is derivative of bottom, but plus 2 is not there. So to remove plus 2, we have to do minus 2, and I have minus 10 as well. Okay, in the next step, natural log of x minus 1 plus, now I want to separate into 2. 2x plus 2 is derivative of bottom, so this is 1, and minus 2 minus 10, that's negative 12 over this into second fraction. So 2x plus 2 over x squared plus 2x plus 5, one fraction dx, minus 2 minus 10, it's minus 12, so minus 12 I can pull outside, and 1 over, in fact minus 12 over this fraction, and I pulled minus 12 outside, x squared plus 2x plus 5. Okay, and this is natural log of absolute x minus 1 plus, the top is derivative of bottom, so this integral is natural log of bottom, x squared plus 2x plus 5 minus 12. This does not factor, so to find the integral we need to complete the square, and as we know, x squared plus 2x plus 5 can be written as x squared plus 2x. So let's add a number so that this becomes a perfect square. This is like x squared plus bx, so we need to add half of b, half of 2 is squared. Half of 2 is 1, 1 square is 1, so we need to add 1 and subtract 1, and we have plus 5. So from these three, that's x plus 1 quantity square, x plus half of b squared, quantity square. If you FOIL x plus 1, multiply x plus 1 by x plus 1, you get this. 5 minus 1 is plus 4. So this is in fact 1 over x plus 1 squared plus 4 dx. Okay, now this integral is 1 over something square, x squared plus 2 square, it's like that. And as we know, there is a formula, 1 over x squared plus a square and dx, or we can have like u, let me write in this way, 1 over u square plus a square du, then that's 1 over a tangent inverse of u over a. Okay, this u, derivative of u is 1 du. Same thing here, x plus 1, though this is x plus 1, derivative of x plus 1 is 1 dx. So this matches with this formula. Then this is natural log of x minus 1 plus natural log of x squared plus 2x plus 5 minus 12 times, using this formula, this is tangent in 1 over a, that's 4 is 2 squared, so 1 over 2, so 12 over 2, which is 6, tangent inverse of u over a, so x plus 1 over 2, that's the final, plus c, and 12 over 2 is in fact that's 6. Okay, so let me show you this integral. Let's just find this integral in slightly different way, this part. Okay, let me copy this over here and I'll come back. So the answer should be, the integral of this should be natural log of this minus 6 times tangent inverse of this. Okay, I'll come back, I'll write over here and come back. So here I want to show you an alternative method to integrate 2x minus 10 over x square plus 2x plus 5. For let's complete the square now, okay, which is x plus 1 square plus 4, as we've seen over here. Okay, x square plus 2x plus 5 is x plus 1 square plus 4. Now let's assume x plus 1 is u, so let u be x plus 1, so that du will be just 1 dx, and this becomes, on the bottom, this is u squared plus 4, and dx is same as du. So we want to write everything in terms of u. So 2x, so u equals x plus 1, or x is same as subtract 1 from both sides, u minus 1. When we let u be x plus 1, that is same as x equals u minus 1. So this is 2 times u minus 1. X is u minus 1. 2 times u minus 1. So 2u minus 2. Because x is u minus 1, distribute minus 10. Okay, and minus 2 minus 10 is minus 12, and we can separate into two fractions now. So this is 2u over u square plus 4 du, and this is negative 12. It's negative 12 over this. So let me write negative 12 outside. So 1 over u square plus 4 du. Now we can integrate. The top is derivative of bottom. Okay, that means natural log of bottom, u square plus 4 minus 12. Now this fits into this formula. Okay, 1 over u square plus a square du, that will be 1 over a, because a square 2 square, 1 over a tangent inverse of u over a. And if we plug u value back, then this will be natural log of u is x plus 1, so x plus 1 quantity squared plus 4 minus 2 divided by 6 tangent inverse of u is x plus 1 over 2. And this is same as what we have earlier, these two terms. This should be same as here. If we expand this, x plus 1 square plus 4, that's in fact x square plus 2x plus 1 plus 4, that's x square plus 2x plus 5. Look at here, over here. X plus 1 square plus 4 is x square plus 2x plus 5. That's the first part. In fact, these are sum of two squares. We don't need absolute value, but just put absolute value, doesn't matter. And next one is same thing, final.